Assalamualaikum everyone. My name is Abdullah Abbas and I'm student of Automotive Engineering and Technology. I'm in fourth semester and today my topic is different types of stress and strain on vehicles. Today we are going to explain what are different types of stresses, strains on a vehicle, how they affect the vehicle, and what actually is the definition of these stress and strains. So let's get to it and we'll move to the next slide now. So now we are going to give the introduction of stress and strain. Stress is basically force per unit area. So it is when you apply a force on an area. This is called stress. This is its definition. And for strain, it's the amount of deformation you get when you apply a stress on a body, and how much its original size, shape, and changes. And its formula is delta L over L. This means the change in size divided by original size, and its importance is determine how vehicle parts partly behave under loads, like you had when you are testing that how much stress a vehicle can obtain and how much stress that it can hold until it breaks or something that happens to it. So that's the introduction of stress and strain. So now we are going to discuss different types of mechanical stresses. First off, we have tensile stress. It is basically a stretching force, like when you stretch something, and the stress applied to it is called tensile stress, and it is basically related to shape. You guys call it shape stress too. And next we have compressive stress, like when you squeeze something and it changes its shape to absorb that type of stress is called it's in compressive stress. Like shock absorbers work on this principle. Lastly we have shear stress. It is basically are the sliding forces, like when you apply stress to something, and the body slides away to hold the stress applied on it is called shear stress. And its example is bolts in a suspension system. A suspension system adjusts bolts and they work on the function of shear stress. So these are the types of mechanical stresses. And now we are going to discuss about types of strains on vehicles. So first off we have elastic strain. It's temporary and is reversible, and so like when we apply a stress on a body, it bends and deforms, but this deformation is only temporary and we can always reverse it, so it's like a reversible strain, you can say that. And next we have plastic strain. Plastic strain is a permanent deformation, like when a body bends, it permanently changes its shape, and the shape cannot be reversed again, so it's like a irreversible strain. And example of it can be a fender bending permanently after impact, like when in the fender hits something, it permanently deforms and changes its shape, and this deformation can't be reversed. So this is the type of strains on a body. Next, we are going to talk about the stress strain curve in automotive materials, and this curve basically shows the behavior of automotive material under the load. Like when we apply a pressure, this curve shows the different points that automotive material goes through. The key points of it are elastic limit. Elastic limit is the limit to which the material can bend and does not deforms, like before I have told about like elastic strain. This is basically elastic strain. Next we have the yield point. This is like a transition point from which a material goes from elastic to the plastic limit, like slowly transitions toward it. Ultimate tensile ultimate strength is the last point to which a material can absorb the pressure strain over it and does not break. The fracture is basically the permanent deformation point of a material. Like after the when any material reaches this point, it permanently deforms and gets fractured. The example of it can be a comparison between steel and aluminum components. Aluminum components have larger ability to absorb stress and do not deform permanently, while steel doesn't have a lot of the absorption power of bearing a lot of strain over it. So that explains this. So now we are going to talk about their applications in vehicles. First off, in the frame of a vehicle, we apply torsional and compressive stress. Torsional stress is basically the twisting force or a torque applied on the frame that makes it rotate about its axis, while the compressive stress is the pushing and squeezing which results in the decreased volume of the frame. The second, we have suspension system stress in which we apply tensile and compressive forces. Tensile is basically, like I've told, that like we push a body to its like we stretch a body to its limit, so that we check the changes in it and in the different step, while the compressive stress is the same one that we apply in the frame of a body. Last one is the engine mounts. In engine mounts, we apply vibration and fatigue stress. Like when a car engine is running, it vibrates violently, so we put it through a vibration stress, so that we can see how long can how much vibration can it stand. And last one is the fatigue stress. Like we put it through a lot of work to see how long till engine mounts can work until they break or get fractured permanently. So now we are going to talk about real world testing methods. First off is crash testing. Crash testing is like when you crash a car, what different type of stresses it gets applied on it, and we test how much of a vehicle or its component can hold stresses during a crash. Next is finite element analysis. Finite element analysis is a computerized method for predicting different types of real world forces of products experience. These forces can be vibration, heat, or other type of forces. Lastly, we have road load data acquisition. Data acquisition is basically a method of measuring different loads and stresses on a vehicle while being driven in real world, like putting sensors on a vehicle and driving it on bumpy roads, plain smooth roads, or like in a dirt area or different types of conditions, and acquiring that data and using that. So this is called road load data acquisition.